So, we pick up where we left. The strain boosted electrical performance in silicon nanowire FETs using non-equilibrium Green's function model. Here we have studied the basic characteristics of the drain, that is the drain characteristics and the transconductance characteristics of our structure. However, as long as the transconductance and drain characteristics are concerned, we find that for 1/4 embed, for half embed, for 3/4 embed, for all the cases, there is quite a lot of changes in the structure than the unstrained as compared to the unstrained one. NEGF model more or less approximately gives us the correct results. However, there is a lot of NEGF model is kind of a black box model, and so there are a lot of scopes and rooms for improvement in the NEGF model, where we can tailor our Green's function approach as per our needs, as per our necessities, like which portion to be more subtle compared to the others. Not just rely on normal NEGF models or NEGF black box software. So this is the future scope, and of course this is all theoretical research, so it will be excellent if we are able to fabricate, at least if maybe not in the 10 nanometer range, then in the 20 nanometer range, if we are able to fabricate this 20 nanometer range nanowires and actually vary their depth of immersion into the underlying substrate, actually change the high K dielectrics that we have used to get the correct results, and then we can check that how much correct is our NEGF model as far as the threshold voltage, subthreshold swing, DIBL, transconductance, etc. are concerned. So this is actually the concluding portion of my lecture at IIT Dhanbad. So my future scope, my future emphasis is purely on fabricating this kind of, which I am confident enough that in an esteemed institution like IIT KGP, I'll be able to collaborate with such labs where we'll be able to fabricate this kind of devices and actually check how much merit this strain engineering technique has as compared to this new strain engineering technique has as compared to the traditional ones. And finally, we present some material comparisons. That is why we are choosing which material, like silicon and sapphire Al2O3. As I have said, their mismatch is such that can induce quite a good amount of strain in the structure, in the silicon structure, because sapphire is thick and it won't be much impacted by the thin silicon layer or a thin silicon nanowire. However, that amount of strain, which is a very big amount, can be modeled as per our necessities. So if these things, when we actually fabricate these devices, there certain issues will come up. We'll be handling those issues, and this of course will lead to the fabrication of symmetric CMOS, symmetric silicon CMOS, in fact a dream that has not yet been achieved in the semiconductor industry. Thank you.